Hello, this is the 12th ICP, and then so we have the sentiment data set. So we import that in, and we only got the text and the sentiment, as you can see. And then we pre-process the data by lowercasing and then replacing all the punctuation, as well as replacing all the RT, which stands for retweets. And then we're gonna tokenize and then fit on text the text values. And then we also use pad sequence, and then we binarize the Y labels, which was the sentiment. Got the shapes, which we're going to input into our embedded sequential model. As you can see, we did the x.shape1 and y.shape1, and as well as use activation equals softmax. Split the training and test data, got the shape, got the model summary, and then fit the data, and then saved our model. And then our accuracy for the sentiment data set was 65%. Now for the spam data set, we just did the same thing, except for encoding had to be different from UTF-8 because it just was not working with UTF-8. And then we saw the header, and then we didn't need the unnamed column, so we only got V2 and V1, and we swapped it because we want the same format as the previous data set, just tuning things up for a bit. And then we pre-processed the data as the same as before. We even did the RT, even though we didn't have to, but it was just the same code. And then we applied the same sequential model with the X and the Y, and then this time it was the output layer was 2 instead of 3 in the last data set. As you can see, our model summary. And then I was worried about overfitting, so we had the early stopping callback, but we got a pretty good accuracy with 98% accuracy.
Okay, so then we did the transfer learning, and we kind of followed this tutorial here to apply the ImageNet classifier to the cats and dogs data set. So we loaded in the cats and dogs data set, and we kind of got the size of the training, testing, and validation sets. We visualized the images, so this is similar to what we did with the handwritten digits data set by visualizing each image, and also their class, so 0 for cat, 1 for dog. Then we resized all the images to be a uniform shape of 150 by 150. We batched the data and pre-fetched it, which basically speeds up the training process down the road. We also did data augmentation, so this will either randomly flip the image or rotate it by 0.1. And then we visualize, this is what the data augmentation looks like. So you can see each image is slightly different. So then we built the model. We needed to get the general layers from the ImageNet classifier. So we excluded the top layer, and we set the weights of these base layers to be false so that we don't train those weights. We then created the topmost layer. So we have the input shape, we have the data augmentation, which feeds into the space model, and then also the scaling layer. That all feeds into the base model. And then our top layers are a global average pooling layer, dropout layer, and then a dense layer. So these are the newer layers that will be trained. We create the model, got the model summary. We use binary cross entropy, accuracy, and atom optimizer. And after the first round of training, we got an accuracy of 97%. But then we can also go through and fine tune the model. So we basically unfreeze the weights of the base model so that we can go and train those layers. And those base layers have image detection for general things like lines and curves, while the topmost layers have the more specific filters for things like ears and eyes and noses. So we can fine tune those first layers with a very low learning rate. And we finally got a validation accuracy of 98%.